Hello everybody, welcome to the Math for Programming course. In this video, I'm going to discuss the use of algebra for computer programming. So, what is algebra? Algebra is the art of solving equations and finding patterns. So for programmers, algebra is the foundation of algorithms, AI, graphics, and data science, and so on. So let us talk about the first section of algebra, which is called variables and expressions. So what is a variable? A variable is just a named container for a value. So we can let x be 5, so the variable x becomes a container to store the value 5 here. And here we have a name equals Alice statement. It means that the name variable will store this string called Alice, okay? And here I've another example of a variable. The name of the variable is called velocity, and it is going to store 9.8. So for velocity, the unit should be meters per second, not per second squared. Okay, so this 2 has to be deleted. So let us see how we can implement the declaration of variables in Python. So it is easy. I just use the variable name followed by the equal sign followed by the value to be put into the variables. So here remember that for velocity, the unit has to be meters per second, not meters per second squared. So after that, I can just print out all the variables in just one printline statement. So you can see that I'm able to get 5, Alice, and 9.8 from all the 3 named variables, okay? Now let's talk about the other part of section 1, which is called algebraic expression. So we can define a function by using variables, numbers, and operations. And the function is just in the form of an algebraic expression. So here we have a function example, which is just 3x squared plus 2x minus 5. So this is the definition of this function. The right hand side of the equal sign is an algebraic expression, which is this part. So we can see that an x as the variable, and 3, 2, and negative 5 here would just be numbers. Okay, and 3x squared is just the multiplication and the squaring of the variable called x, and 2x is just the multiplication of 2 by x, okay? And I add the first 2 terms together, and then I subtract 5 from the whole term before it, okay? So how can we apply the algebraic expressions? It is easy. Also in game physics, we can evaluate the distance as half times the gravity times the time squared. So I just use an algebraic expression here to find out the distance traveled during a free fall. And for finance, we can use an algebraic expression to write down the relationship between the future value and the principal, okay, which is equal to principal times 1 plus rate to the power of years, okay. So this is the expression. This is also another expression, okay. So let us see how we can use Python to represent an algebraic expression. So we can make a function to denote an algebraic expression. So I just enter a quadratic equation into the function. So this x can be any number that will be put into the function, and then the function is able to evaluate the value of the function when x is given. So when x is equal to 2, I will be able to get 11 from the quadratic function. So let us run the program. So you will see 11 here, because when I put 2 into this quadratic equation, I will be able to get 11 according to the step shown here, okay? 12 plus 4 minus 5 equals 11. So for point number 2 of this video, we are going to discuss the way to solve linear equations. So let us see the situation when there is only one variable in the linear equations. So we can put a variable on one side of the equal sign and other variables or numbers on the other side of the equal sign. So that is the way to solve the equation. So suppose I have ax plus b equals 0. When I put b to the other side, I have to do subtraction of b on both sides so that the right hand side will have negative b. And for a here, I want to remove it to the right hand side. And the way to do so is to divide both sides by a, so that the a on the left hand side will be cancelled out and the a on the right hand side will still remain. That's why I will have x equals negative b divided by a. So how can we apply the solving of linear equations? We can use it in the break-even analysis in business. And also we can use it to solve the temperature conversion easily between the Celsius degrees to Fahrenheit degrees. Okay, so let us see how we can do this solving in Python. So if we have only one variable to solve from a linear equation, we can make a simple function to do so. So I want to solve ax plus b equals 0. So how can I do it? I can make a function like this one. I need to check whether a is equal to 0 or not. If it is equal to 0, I will have no solution because a cannot be 0. It can be any other number. So that this division is allowed, okay, if it is not equal to 0, okay. So if a is equal to 0 and at the same time b is not equal to 0, then I will have an infinite number of solutions. So let us see how to solve a linear equation with one variable. So I can make a function like this one. The function is like this. I have to check whether a is 0 or not. A is the value followed by x, okay, which is the coefficient of x actually. So if the coefficient of x is 0, I will have no solution if b is also non-zero. If a and b are both zeros, I would have an infinite solution. That's why I will have the else part here to consider the case of a and equals 0 together. Okay. And if I have a equals a non-zero number, I can just say return minus b over a, which is just the result coming from the nots here. Okay. So I'm able to handle the situation when a equals 0 and at the same time b is equal to 0. Okay. So when I put a as 2 and b as minus 8, I'm able to get x equals 4 because I just used this function to do negative b over a as the answer. So let us run it. Yes, you will see 4.0 as the answer because a is not 0 and I'm able to go to this part, which means the return part. Okay. So how about the case if I have a system of linear equations in two variables to handle? Let us see the example here. a1x plus b1y equals z1 and at the same time a2 times x plus b2 times y equals z2. So I have to solve for x and y. How can I do so? I can use the Cramer's rule. So here I just put the coefficients of each of the equations into this equation for x and this equation for y. So det here means the determinant. So you can see that I want to find the determinant of this matrix and that matrix in order to find out the value of x. I also need to do the determinant of this matrix divided by the determinant of this matrix to get the value of y. So we can use the Cramer's rule shown here to help us evaluate x and y from the system of linear equations with x and y being the unknowns. So how can we apply the Cramer's rule or the solution of the system of linear equations? We can use it in the traffic flow modeling, and we can also use it to handle the circuit analysis, for example, the Kirchhoff's laws of circuits. And we can also use it in economics to find out the equilibrium point of the supply and the demand curve. So let us see how we can implement the Cramer's rule in Python. So we can write the solution as here. I want to solve for a system of equations in two unknowns and also having two equations. And I can use the determinant function coming from the linear algebra submodule of the NumPy module here. Okay. So if the determinant A is very, very small, I will say that I will have no unique solution. It means that the solution cannot be solved because the denominator here will become a 0 number, okay, or a value that is very close to 0 numerically. And if it is able to ensure that the determinant of this matrix is not equal to 0, I can do the solution by using the solve function, okay. So I have a matrix here to denote A, and I have an array here which is in the form of a vector to denote B. So I'm able to do this solution to get x equals 1 and y equals 1. Okay, so let me play the program. Yes, I am able to see 1 here. So that means 2x plus 3y equals 5 and 4x minus y equals 3. So I have these two equations in two unknowns, and then I'm able to use this function to solve for x and y for me. Okay. Now, let us talk about another point of algebra called functions and graphs. So, what is a function actually? In the function, we have a variable as an input, and then the function is treated as a process, and then the output is the function value obtained after the process is done. That is the fundamental concept of a function. So, a function can be written as y equals f of x. And for a linear function, f of x can be equal to mx plus b, where m and b are real numbers. So when we put x into this function, I will have a function output. So input is x, the process is this function content, and the output is just f of x, okay? So for a quadratic function, I will have f of x equals ax squared plus bx plus c, where a and b and c are all real numbers, and a cannot be 0, okay? For an exponential function, f of x equals a times b to the power of x, where a and b are real numbers. So x here becomes the power, okay? And for a logarithmic function, f of x equals log x with base b. This is the subscript called b, where b has to be larger than 0. So how about the application of functions and graphs? We can use them to model the growth of population and viruses. And we also use the logarithms or the powers to help us denote the algorithm complexity. And also we can use these functions in machine learning. For example, when we want to define the loss functions, we have to use virtually all these kinds of functions to help us write down the loss functions. So let us see how we can implement functions and graphs in Python. So here I'm going to have x values in the form of vectors in the linear space. And then I have so many functions here. A linear function, a quadratic function, an exponential function, and a logarithmic function. Okay, so I'm going to plot all these 4 functions on the same graph. Okay, so I can use the plot function of the matplotlib module, and I also set the label and the color of each of the graphs. And I can also do the styling of the whole graph by setting up the title, the X label and the Y label, the legend. So let's see how I can show all these 4 functions. So you can see the graph here. The linear function, the quadratic function, the exponential function in red, and the logarithmic function in purple. Okay. So I'm able to do the plotting of each of these 4 functions. Okay. And I'm able to set up the y-axis and the x-axis. And you can see that an exponential function would grow very rapidly, even with the same values of x for all the 4 graphs shown here, okay? And number 4, it is about quadratic equations. So a quadratic equation is going to make a quadratic function to equal to 0. So we have the standard form as follows. Ax squared plus bx plus c equals 0, where a, b, and c are all real numbers, and a cannot be 0. So that is the standard form of a quadratic equation. We are able to solve for this equation to get the value of x if we know a, b, and c, okay? How can I do so? I can use the quadratic formula here. So we need to solve for x from the standard form shown here. So if we have 0 on one side and the quadratic function on the other side, a, b, and c will be known, and we can use these known a, b, and c to solve for x by using this formula, called the quadratic formula. There are 2 solutions coming from the quadratic formula because we have plus and minus here. It is sometimes necessary to reject one of the solutions coming from the quadratic formula so that we can make sure that the result can conform to the context of the question. So it is sometimes necessary to reject one possible answer, even though we have 2 of the answers coming out. Now let us see the application of the quadratic equations in programming. So we can use it to model the projectile motion in physics. So it is possible to have 2 solutions coming from a projectile motion. And we can also use quadratic equations to solve for the intersection of curves. So we may have some curves in quadratic format, and we are able to do the solution by solving the quadratic equation directly. We can also solve the optimization problem by using quadratic equations. For example, we can use the solution of the quadratic equation to help us find the minimum cost of a project. So let us see how we can implement the solving of a quadratic equation in Python. So here we have a function that uses the quadratic formula shown here. And it is possible that the value of the roots will be in complex numbers. So it is quite helpful to introduce the CMath module so that I'm able to show the answer in complex numbers. So if I have a equals 1, b equals -3, and c equals +2, I can use this function to help us solve 1x squared minus 3x plus 2 equals 0. And I'm able to have two real roots. And you will see that the imaginary parts of the two roots will be 0. Yes, I'm able to show this answer. So I'm able to say that all the two roots are real numbers. Okay. So I have two roots coming from the quadratic equation. Okay. And let us go to number 5 of this note about polynomials. So what is a polynomial? We have the following general form. P of x equals an times x to the power of n plus a minus 1 times x to the power of n minus 1, so on and so forth until we reach a0. So here a0 would correspond to x to the power of 0. But x to the power of 0 is always 1. That's why I'm not required to show that part. And I'm just able to use the constant to end the entire polynomial. Okay. So an, a minus 1 up to a0 are real numbers. And they are called the coefficients of the polynomial. And n here is the degree of the polynomial. So n is the power on the first term of the polynomial here. Okay. If alpha is a 0 of the polynomial, then I'm able to show that p of alpha equals 0. We can also say that alpha is a root of the equation p of x equals 0. So if we equate the polynomial to 0, alpha will just be the root of this equation. P of x equals 0. Okay. And it could be quite difficult to find out all the roots of a polynomial analytically. Hopefully, we can use some numerical approaches to find the roots, although we have to concern about the errors obtained from those numerical methods. And how can we apply the solution of the polynomials? We can use them in animation curves. For example, the Bezier curves and the splines curves would involve the solution of the polynomial. Okay, and we can also use the polynomials in signal processing. For example, in Fourier series, the solution is in the form of a polynomial. And for cryptography, we can use polynomial commitments to help us solve many problems involving cryptography. So let us see how we can use Python to implement the root finding of a polynomial. So first we can see how to evaluate the function value from a polynomial. So I have to put a list of coefficients into the function, and I also need to provide a point for evaluating the function value. So x will be 2 and the coefficients will be in this list. So I can use this particular function to help us get the sum of the values from each of the terms in the polynomial. Okay, so I have to use the sum function here, and I need to get the coefficient from my list here. And I also have to use the index of the corresponding coefficients to help us evaluate the sum. Okay, so a0 is 1, a1 is -5, a2 is +2, and a3 is +3. Okay, so I here would correspond to the index of each of the coefficients. So this term is the first number in the list. It has an index of 0, and the second number would have an index of 1, so on and so forth. Okay, so we start with the constant and we will end with the highest degree. Okay, so after using this function, I'm able to show that p of 2 is just equal to 15. Okay, oh sorry, it should be 23. Okay, so 3 times 8 plus 2 times 4 is 32. 32 minus 10 is 22. 22 plus 1 is 23. Okay, So this should be 23. Okay. So the answer is 23 when I have 2 as the value to be put into the polynomial. And the coefficients are all these things in the list. Okay. So after that, we can see how to do root finding of a polynomial in Python. We can use NumPy again and set the coefficients of a polynomial in the form of a list. And then I can use the roots function from NumPy, and I put the coefficients into the roots function, and then I'm able to show the roots by using the roots function. So let us run it. So for the polynomial, x cubed minus 6 times x squared plus 11x minus 6 would be just 3, 2, and 1. Okay, so I have 3 roots coming from a polynomial of degree 3. Okay, so the coefficient of x cubed is put first, followed by the coefficient of x squared, followed by the coefficient of x, followed by the constant term. Okay, so I can use the roots function to help me find the roots of a polynomial. Okay. Now let's talk about number 6, which is exponents and logarithms. So let us talk about the laws of exponents first. So a is the base, the superscript is the exponent. What does it mean by this sentence? Let's see here. A here is the base, and m here is the power, or the exponent. So a to the power of m times a to the power of n would be equal to a to the power of m plus n. So this one is called the product law. And we have also the power law. A to the power of m, and the whole thing is taking the power of n. So the answer here would be equal to a to the power of mn, m times n here, okay? And we have also the root law. A to the power of 1 over n is equal to a taking the nth root, okay? So we have another property called logarithm property. So here, when we use logarithm, the little b here is the base of our logarithm. And if we have the logarithm of mn with base b, it is equal to the logarithm of m with base b plus the logarithm of n with base b. So we can see that the product of logarithm can be written as the sum of 2 logarithms, okay? Similarly, for division, m divided by n here, when we take logarithm with base b, the left-hand side is equal to the logarithm of m with base b minus the logarithm of n with base b, okay? And for m to the power of n, if we take logarithm of it with base b, the answer would be equal to n times the logarithm of m with base b, okay? And we have another formula called the change of base formula. Log of a with base b equals log of a with base c, which is another number, logarithm of b with base c. And this c can be any number other than a or b, okay? And we have the relationship between the logarithms and exponents, which is able to help us link the two things together. If y equals a to the power of x, then x is equal to log of y with base a, okay? And we have to notice that a has to be larger than 0. That means both the bases have to be larger than 0 to make this relationship defined, okay? How can we use logarithms and exponents? We can use them in back-end analysis of algorithms. So for example, the number of searches required in a binary search is equal to log of n with base 2, theoretically, okay? And also we can use exponents and logarithms in data compression. For example, the Huffman coding relies on logarithms to help us get the number of bits to store the data. So we can try to implement logarithms and exponents in Python. Now let's see how we can do exponents and logarithms in Python. So let us handle the laws of exponents first. So I can have 2 asterisks to denote the power. So 2 to the power of 3 times 2 to the power of 4. Is it equal to 2 to the power of 7? It should be the same. And how about the rule here? 2 to the power of 3, and then the whole thing to the power of 2 should be equal to 2 to the power of 3 times 2, which is 6. And how about the final one? 4 to the power of 1 over 2 should be just 2. Okay. So let us see if all these things are true. Yes, all these things are true. That means I'm able to verify the laws of exponents by using Python. These rules can be verified by using the Python code here, okay? And how about logarithm properties? I can import the math module first. From this module, I'm able to use the log function, okay? So this is the number to take logarithm, and the second argument is the base, okay? So I'm able to verify the addition shown here, okay? So log 8 with base 2 should be equal to log 2 with base 2 plus log 4 with base 2, okay? And here I'm able to verify the second law of the logarithm process here. Log of 15 with base 3 should be equal to the log of 30 with base 3 minus the log of 2 with base 3, okay? And for the third law here, 2 times log 3 with base 5 should be equal to log of 9 with base 5. So here, 3 to the power of 2 is just 9, okay? And I'm also able to verify the change of base formula here. Log of 16 with base 3 should be equal to log of 16 with base 7, which is another value as c here, divided by log of b with base 7, which is actually my c again, okay? So let us see if I'm able to get all the answers as true. Yes, all the answers are true. That means I'm able to really verify the logarithm properties, okay? Number 7, sequence and series. What is a sequence? It is just a group of terms following some definition. So let us see an example of an arithmetic sequence. So in an arithmetic sequence, the terms would be like that. A1 as the first term, A1 plus D as the next term, A1 plus 2D as the third term, and so on and so forth. And the final term is just A1 plus N minus 1 times D. So A1 is the first term of the sequence, and D here has a name called the common difference of the arithmetic sequence. So the common difference is like a given term minus the previous term would be always equal to D. So when I pick the third term, and if I do the third term minus the second term, I'm also able to get D as the common difference. So that is the meaning of the common difference D. And the general term, which is the nth term here, is always equal to the first term plus n minus 1 times d, okay? So an here is the nth term of an arithmetic sequence. Another sequence is called geometric sequence. So the terms are a1, a1r, a1r squared, and even more until we reach a1 times r to the power of n minus 1. So a1 is the first term, and r here is the common ratio of the geometric sequence. So how can we obtain the common ratio? We can divide the term by the term just before it. So I can have a1r divided by a1 to get r, or I can have a1r squared divided by the a1r to get r as the common ratio, okay? And the general term, which is called the nth term as well, is just an equals a1 times r to the power of n minus 1. An is the nth term of the geometric sequence. And how can we get the sum of all the terms in an arithmetic sequence up to the nth term? We can have this formula. The first term here plus the second term plus the third term up to the nth term will be equal to n divided by 2 times 2a1 plus n minus 1 times d, okay? And for the sum of the terms in the geometric sequence up to the nth term, we can have this formula. The first term plus the second term plus the third term plus the final term, which is the nth term, is equal to a1 times 1 minus r to the power of n divided by 1 over r. And we have to notice that r, which is the common ratio, cannot be exactly equal to 1. Okay, that is the rule that we have to obey when we use this formula to get the sum of the terms in a geometric sequence. So how can we apply geometric sequence or arithmetic sequence? We can use them in algorithms. If we do the divide and conquer recurrence relations, we need to use the arithmetic sequence and the geometric sequence, okay? So let us see how we can implement arithmetic and geometric sequences in Python. So let us talk about arithmetic sequence first. So I have a function to help us get the nth term, and I've also another function to get the sum of all the terms in an arithmetic sequence up to the nth term. So the general term is just that one by using the formula shown here. Okay, and the sum of all the terms in the arithmetic sequence is just using that formula. Okay, so if I know the first term as 2 and the common difference is 5, and I have 5 terms, I'm able to get the fifth term as 14. And I can also find the sum of the arithmetic sequence terms from the first term as 2 to the final term as 14. Okay, so it is just doing 2 plus 5 plus 8 plus 11 plus 14. So let us see the result. So of course the fifth term is 14, and the sum of the first 5 terms in the sequence is just 40. Okay. And how about geometric sequence? We can make the general term as a1 times n to the power of n minus 1, which is just this formula. And we can also find out the sum of all the terms in a geometric sequence by directly typing this formula into the code. Okay. Of course, we have to check whether r is equal to 1 or not. If r is not equal to 1, we can really find out the sum. But if it is equal to 1 exactly, instead of having a runtime error because the denominator is now 0, I can just print out a statement showing that r cannot be 1 to avoid the situation of the runtime error. Okay, so I have the first term as 3, the common ratio as 2, and I have 4 terms. So I will have this geometric sequence 3, 6, 12, and 24. So the 24 here is the 4th term. And the sum of all these terms is just equal to 45. Okay, so let us run the program. Yes, you will see the 4th term as 24 and the sum of all these 4 terms as 45. Okay. Now the final part of this video is about inequalities. So for inequalities, we can solve x in the form of a range. So suppose I have ax plus b larger than 0. I can just show that x is larger than negative b divided by a, if a is larger than 0, okay? And how can we apply inequalities in programming? We can use them in constraint programming. We can use them in optimization such as linear programming process. And we can also solve inequalities in game AI to help us do the resource checks. And let's see how we can implement the solving of inequalities in Python. So I want to solve for this inequality, ax plus b larger than 0. Of course, I have to make sure that a is larger than 0 before I can solve the inequality, okay? So I want to make a user-defined function to help us solve the inequality. So I have to make a function that has a, b, and the symbol into the parameters of the function. And I have to check whether the symbol here is a larger than sign or not. If it is a larger than sign, I just print out negative b divided by a as the answer. And of course, I have to check whether a is really larger than 0 before I return the value of the inequality as negative b divided by a. If a is not larger than 0, I would just say no solution, because this inequality would fail to be satisfied. And we can make similar functions by handling the inequalities involving less than sign, larger than or equal to sign, or the smaller than or equal to sign. Okay, so we can change the function content according to the inequality sign that we need to handle. Okay, so let us see this example by solving 3x plus negative 5 larger than 0. So I will have the result as x has to be larger than 1.66667, okay, which is just evaluating this inequality directly by typing this result into the Python code, okay. And we can also solve inequality by the use of the module in Python. So we can use SymPy, and from SymPy we can import symbols submodule and the solve univariate inequality submodule. And we also need to import the symbol as x. Okay, that's why I have to import it first by using the symbols function. Okay, so x will be the symbol, and I want to solve this inequality, x squared larger than 4, and I use the solve univariate inequality submodule to help me do so. I need to put the inequality into this function, and I also need to put x, which is a symbol, into the function. So the submodule called solve univariate inequality here will be able to denote the variable, which is x, and the inequalities to solve, which is this one. Okay, and let us see the solution coming out from this submodule. Yes, you will see that for x squared to be larger than 4, we have two possible ranges of values. X can be less than 2, or x can be larger than 2. Okay, so this symbol is meaning infinity, so this is negative infinity, and that thing is positive infinity. Okay, so x can be less than negative 2, or x can be larger than 2. Okay, and here, if we want to join the two things together, the combined result will be just x less than negative 2. And if we want to join the two parts together by using the AND symbol, it is just that x is larger than 2, okay, or 2 is smaller than x, okay. So that means we can get the solution by using the built-in modules in Python, okay. So this video has discussed a number of things about algebra for computer programming. We have learned variables and expressions. We have learned algebraic expressions in the form of a function. And we know how to solve linear equations in one variable only. We also know how to solve the system of linear equations in two unknowns by using the Cramer's rule, okay? And we also know how to plot functions and graphs by denoting the function first, followed by plotting it by inputting a number of input numbers. And we also know how to solve the quadratic equations by using the quadratic formula here, okay? And we also know how to set up a polynomial, and we can evaluate the roots of the polynomial by setting p of x equals 0, and then we solve for this equation to get the value of x as the root of the equation. And we also learned the exponents and the logarithms together with the corresponding laws of exponents and logarithms. We also learned the way to set up the arithmetic sequence and the geometric sequence. We also know how to get the sum of the first n terms in an arithmetic sequence or in a geometric sequence. Finally, we have experienced the way to solve inequalities in the form of ax plus b larger than 0, and a is a value larger than 0 as well. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.